Alright, this is the number 9 from the homework, number 2 for physics. And let's take a look at it. So it's asking us what is the angle, or the theta, between the A and the positive direction that would cause them to collide. So here is my numbers, your numbers will be different. So the easiest thing to remember is to separate X and Y, because it makes it way easier. Because as he said, they're distinct, so we can consider them separately. So we know for the A of X has to equal B of X in order for them to collide. By the way, if you see this, this just means multiply. So we can write A of X as velocity times t, because we're just given the velocity and the distance it travels just times t. That gives you distance. This is the distance, and this is just the 1/2 at squared, which just means 1/2 of the acceleration in the x direction times time squared. This gives you the distance of acceleration, and for the reason why it's 1/2, well, at constant acceleration, your average speed is exactly half of your max. So yeah, this is basically just the distance formula, but there's no v initial speed because b started at rest. So let's simplify this equation right here. So we just divide both sides by t. So from here, this t squared just turned into t. And we want to get t by itself, because we want to have the unknown, which is the time, on one side, because we know the velocity and we know when we can find the acceleration. So in order to do that, first of all, I multiply both sides by 2 to get rid of the 1/2. And then I just moved everything to this side and left the t by itself to get to here. And then now we have the acceleration in the x direction equals 0.48 meters per second squared sine theta. Why sine theta? Okay, so we know the acceleration of this in this direction, like the total magnitude is 0.48 meters per second squared. So we want the x direction. This is the x direction up here, and this happens to be opposite of the angle. And what's opposite over the hypotenuse? Sine. So that's why we use sine theta for the x direction. For this reason, I won't explain again later, for the y direction, we use the adjacent over the hypotenuse, which would give us cosine. Would give us cosine theta. So for the y, we will use cosine theta. That'll be later though. So for now, for x, we have the sine theta. Remember that. And then, let's see. So then we just plug in this for a of x in this equation. So then we have this here. And then we work out the math, and then now we're here. We do not know sine theta, but we're going to plug this into another equation later. So then we're going to do the exact same thing for the y. Y we know is 31 meters, and we know y equals 1/2 ay times t squared. It's literally just where is it? It's just this again, except here we have y instead of vt because it's not changing, it's just 31. And here instead of ax we have ay. It's just the exact same thing. So as I said, ay is 0.48 that times cosine theta. So then we just plug in this for ay into this equation, and we get this. This line is going to be very, very important for the end. Just make note of this. Oh, well, I already made note of this for you. But this is just, I plugged in 31 for y right here. So then remember that we set t to equal this right here. And we have a t right here. So whenever we see t, we plug in this number right here, because we got that up here. And then this is what you get. So that's all the physics. And next it will be all calculus. I'll work through the calculus in a different video.